Day 177 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another LeetCode, another day, another LeetCode problem. This time we're at day 177, and I don't see any sign of slowing down anytime soon. So I hope y'all don't feel any effects of burnout, and I hope y'all plan on not slowing down or stopping anytime soon either, because we have a long way to go, y'all. They say if you want to master something, it takes 10,000 hours. We're not even 1,000 days in, so that should let you know we have a long way to go. So I need y'all to wrap your mind around the fact that we're just getting started and prepare yourself mentally for this journey we're about to go embark on. This journey is going to require a lot of discipline and a lot of consistency, and for all of us to stay focused so we can accomplish our goals in the end, whatever they may be. You can apply that to any part of life, but right now we're applying it to LeetCode so we could be the best programs that we can be, y'all. We do not want to let anybody get in the way of our dreams. We do not want to let the naysayers get in our head. We're not worried about imposter syndrome. We could do whatever we want to do as long as we stay focused and put effort into it and stay disciplined and staying consistent, y'all. The motivation part is good, but it's not always going to be there. So you have to plan for when the motivation leaves. You have to plan that I know when I start to lose motivation, I'm going to keep staying disciplined and keep pushing through until the motivation comes back, because it will come back one day. And when the motivation comes back, you'll be happy that you stayed disciplined throughout the whole time that you weren't motivated, y'all. So that's what we're here for, y'all, to help encourage each other and help push each other to accomplish the goals that we all know we're capable of achieving. Sometimes you just need somebody to tell you that you can do it and not to give up, y'all. So that's part of what this channel is about. So before we get started today, y'all, don't forget. Bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we can push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community to grow, and one way we could do that is to share this content out with as many people as we could find that will watch it, y'all. So y'all support is appreciated when it comes to that, y'all. So let's get into the question, and today we have question number 1028, number of equivalent domino pairs. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well, because we're all here to learn something. And if you don't understand the solution at the end of this video, then you probably didn't learn anything. So let's get into it. The question says, given a list of dominoes I equals an array AB is equivalent to dominoes J, which equals an array CD. If and only if either A is equal to C and B is equal to D, or A is equal to D and B is equal to C, that is, one domino can be rotated to equal the other domino. Return the number of pairs IJ for which 0 is less than or equal to I is less than J, and J is less than dominoes.length, and dominoes I is equivalent to dominoes J. So let's break that down. Let's look at the example so we can see what it is that they're talking about. In example 1, we have the input dominoes. It's a 2D array. The arrays inside of an array are 1 and 2, 2 and 1, 3 and 4, and 5 and 6. The output is 1 because there is only one pair that we can create that fits these parameters up here, or these requirements, right? So A has to be equal to C and B has to be equal to D, or A has to be equal to D and B has to be equal to C. In this case, we're looking at this requirement right here for example 1. Remember, so this is A and this is B and this is C and this is D. So in example 1, A, which is 1, is equal to D, which is also 1. That fits this requirement right here. Then let's look at B. B is equal to 2, which is also, C is also equal to 2, which fits this requirement right here. B is equal to C. And this is the only pair that we can create out of this input. That's why the output is 1. So let's look at example 2, where it's we have a little bit more pairs, so we can make it make sense a little bit more. In example 2, we have the input dominoes is a 2D array of integers, an array inside of an array, and the first array is a 1, 2, then the second array is 1, 2, third array is 1, 1, fourth array is 1, 2, and the fifth array is 2, 2. The output is 3. The output is 3 in this example because there are 3 pairs we could create that fit this requirement, right? And in this case, it will be this requirement. A has to be equal to C, and B has to be equal to D. So this is A again, and this is B, this is C, and this is D, right? So in this example, we have one pair right here. A is equal to C. Boom, that works. Then B is equal to D. Boom, that works. So that's one pair. Then we could do it with this pair. We could say this is A, this is B, this is C, this is D. Same thing. A is equal to C. B is equal to D. Boom. That's 2 pairs right there. This one right here, that's our second pair, and this right here is our first pair. But there's one more pair. This is the last pair. This one and this one, right? So this A and this, if this is A and this is B and this is C, and this is C and this is D, then A is equal to C, y'all, and B is equal to D, and that will be our third pair. Whereas the first pair is these two, second pair is this one and this one, third pair is this one and this one. Or you can switch it up in any order, but those would be the 3 pairs. So now that we understand the question, y'all, let's get into the solution, the fun part, the part that keeps us excited to get up in the morning, the actual code. So let's get into it. The first thing we are going to do is we are going to declare a variable called count, y'all, and we are going to set that equal to, or actually, back up. We're gonna create a variable called pairs. We're gonna set that equal to 0. We're gonna come underneath that, and we are going to declare another variable called dict, and we are gonna cast that as a 2D array of integers like this. It's going to be an array of integers inside of an array, and we're gonna initialize that with, or no, excuse me. We're gonna make this a dictionary. So this right here will be the key will be an array. The value will be just a regular integer, and we're going to initialize that with a blank dictionary. Then we'll come underneath that, and we are going to say for domino and dominoes, what we are going to do is we are going to say let domino equal domino dot sorted. Boom, just like that. Put the parentheses at the end. Then we're going to say pairs plus equals dict, open up the square bracket, domino, comma, default, colon, 0. So what this is going to do is it's going to sort the dominoes, and what this is going to do is it's going to create the dictionaries that we're going to be working with. With the default, it's going to be the key is going to be the domino, and then the default we're going to set to 0. Then we're going to come down here, and we are going to say dict, open up the square brackets, domino, excuse my spelling, default, colon, 0, and then we are going to say plus equals 1. So this is pairs is going to hold the value of the pairs, and then we're going to increment the default value of the dictionary down here, and then we're just going to come down here and we are going to say return pairs, y'all. So let's run it. LeetCode changed up their UI again. Let's run it, see how it runs. Let's see, fingers crossed. Ooh, look at that, y'all, and it's accepted. So let's submit it, make sure it stays accepted because you never know. Let's see. Oh man, y'all know I love those numbers. 7 milliseconds beats 100% of users with Swift, y'all. That's faster than a Bugatti riding past all the brokies on the highway, y'all. That's what I like to see. That's what I like to see. So get one more look at the code, one more look at the code. I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.